Hi, welcome to my kitchen. Not my kitchen, my parents' kitchen, but you get the idea. I'm here to present my presentation on experiment 11.1. Chapter 11 as a whole is about waves. Chapter 11.1 is specifically on sound waves. So there's three things you need to know about sound waves. 1. Sound waves are longitudinal. 2. The frequency is the primary factor in determining the pitch. And 3. The amplitude determines the volume. We're going to need a couple things for this experiment. You're going to need a 6-inch piece, a 6-inch piece of copper pipe, and a 4-inch piece. We're going to need a sink, a large bowl, and a freezer, which is right here, but you can't see. Obviously, the safety goggles and the large gloves, but safety goggles. The first step of this experiment is to take 6-inch pipe, plug the bottom of it with your finger, and then purse your lips and blow into it until you get a clear tone. I got it there for a second. Ah, I got it. Now that I've got it finally, we'll vary the force in which I blow into the pipe. Boom. Alright, let's do the same thing with 4-inch pipe. I shall take that and alternate with the force in which I blow. Now I got both here. I'm going to see if I can get it so we can hear the difference in the tone. Take this pipe and put it in the freezer, a 6-inch pipe, for 15 minutes. So, put that there. Alright. Alright, while that's going, we're going to run the tap water to see as hot as it can go. So, alright, now that we got this water really hot, take our others, when we fill this bowl up, right here, we'll take our other 6-inch pipe, and we'll put it in the cold water, in the hot water, excuse me. And now, we wait. We got about a minute left, so I'm going to explain what I'm going to do here. I'm going to take that pipe out of the freezer, and do the same thing, and we're going to note the pitch. Oh, it's cold. Awesome. Hot, cold, sorry. Alright, now we take the hot pipe, and do the same thing. Alright, the first thing we learned was the pitch from the sound coming from the pipe was not altered by my
hold on there, past self. I'm coming to save the day. So actually, the pitch of the sound coming from the pipe was not affected by the force. And that is because pitch is primarily determined by the frequency of the wave. And the length of the the length of the pipe fixed the wavelength product in the air inside the pipe, therefore fixed the frequency. So no matter how hard you blew, the pitch stayed the same. Also, the harder you blow, the louder the sound becomes. That's because the harder you blow, the stronger the compressions of air in the wave, which means a larger amplitude of sound waves. Therefore, we can conclude that amplitude determines the volume.
When we compared the 6-inch pipe to the 4-inch pipe, we noticed that the 6-inch pipe had a much...
Again, past self, I'm here for you. I have the answers. The longer pipe produced a lower pitch. That's because the longer pipe produces a wave with a longer wavelength, and we know that a longer wavelength means a lower frequency.
That is the conclusion of experiment 11.1. See y'all later. Bye.
Whoa, no. We're not done. Past self, there's one more thing that we can conclude from this experiment. So in the last part of the experiment with the hot and cold pipes, the hot pipe's pitch was higher than the pitch of the sound produced by the cold pipe. Since we know the pipes were of equal length, we know that the wavelength must be the same in both pipes. So if the pitch of the sound wave was higher in the hot pipe, what does that tell us about the speed? It means that the speed was higher. And according to equation 11.1, the only way the frequencies could have been different is if the speed of the waves was different. Therefore, we can conclude that higher temperatures equal higher speed of sound. And finally, that concludes experiment 11.1. Thank you. Gotta come back to stop